Hey everybody, Trey here. Welcome back to another forecast discussion. We have another severe weather event on tap for tomorrow, Thursday, November 30th, as this second severe weather season starts to finally rev up a little bit. We have an enhanced risk level 3 out of 5 in place for tomorrow, again, Thursday, November 30th, in the orange area here. So that includes the northern portions of the Houston metro area up to Lufkin and areas in between, the I-45 corridor north of Houston and areas in between, under the gun for the greatest threat for severe weather tomorrow. Slight risk, level 2 out of 5 surrounds that, basically from Victoria to the east along the Texas coast toward Galveston, over toward Lake Charles, Louisiana, and a large marginal risk extends all the way up to the Red River vicinity into southern Oklahoma, places like the I-35 corridor south of the OKC metro, Ardmore, Dallas-Fort Worth under the gun for a marginal risk, Waco, Austin, Longview, Tyler, Texarkana, Paris, all those areas under the gun for the level 1 out of 5 marginal risk. There is going to be an all-hazards threat tomorrow, although the tornado threat is expected to be the greatest threat tomorrow. We have a 10% area in the yellow, basically coinciding with the enhanced risk area surrounded by a large 5% area and 2% area that extends all the way back to the Austin-Victoria corridor there into south central Texas. But tornado threat definitely going to be the highest of the three main severe weather hazards risks for tomorrow. We do have a damaging wind risk that does extend all the way up to the Red River, basically Wichita Falls to Ardmore, Denton, Dallas-Fort Worth under the gun for the damaging wind risk. But it is a low-end risk as well as a hail risk. Again, hail not going to be a major risk for tomorrow, but we do have a 5% hail risk for tomorrow in the Brown area. So you folks in the Dallas-Fort Worth Metroplex, you're going to be under the gun for a few severe storms. Perhaps they're not going to be surface-based storms. They will be elevated storms. So maybe an isolated hail, isolated damaging wind gust or two up there. But the main threat is going to be down here in southeast Texas from the Houston metro northward. That is where the enhanced risk is located, and the greatest threat for a few tornadoes is going to be for tomorrow. So let's dive into the setup real quick here. We'll take a look to start off with our water vapor satellite imagery. Not a whole lot going on right now, but you see this little bit of a swirl here out across the west coast. That is our next trough that is coming in that will be our weather maker for tomorrow. Here is our 500 millibar map at the present, and you can see that trough starting to dig down into the Southern California, Baja California Peninsula area at the moment. That's going to continue to dig down, take on a negative tilt as it goes into tomorrow, and eject into the southern plains. As it does so, we will see some low-level response, but of course, right now we have not seen strong westerly or southwesterly flow traverse the Rockies, so we do not have a very strong low-level response at this point. You don't see much going on there at 850 millibars. Surface map, pretty quiescent at this point. Surface ridging here off the Gulf Coast, on the Gulf Coast states there. Some high pressure in place there. And then as we get this low pressure to develop tomorrow, somewhere across the Texas vicinity, that will create a pretty strong pressure gradient between these two areas, and that is going to have a big impact on the low-level flow. We'll talk about that as we look at some model data here in just a second. But that is going to really enhance the low-level jet across this region, pull that moisture northward into Texas, and allow for a robust low-level moisture environment for potential severe weather. Let's take a look at our surface data now, and we'll see that we don't have that moisture onshore yet. It's still well offshore. We don't see any 60s dew points here, even in the western Gulf at this point. The moisture is still well offshore, but again, as we get that very strong flow to develop, we'll get a surface low to develop somewhere in this vicinity here probably tomorrow morning. That will start to back and strengthen these winds out of the southeast and really pull that moisture northward. Plus, we have the very strong low-level jet that will be in place, and that will allow that moisture to really surge northward into East Texas and allow for a severe threat there. All right, let's go right into some model data right now. This is going to be the 12Z NAM from this morning, so the most recent run of the NAM model. We're just going to look at this particular model for now. We won't look at a bunch of different models as we do usually when we're a couple days out. But the NAM, the solutions are pretty locked in, so the NAM should be a decent proxy for the other models as well. So here we are at 500 millibars, that trough you see off the west coast starting to dig down. And as it digs down into the southern portion of the country, western Mexico, it'll start to take on a very nice negative tilt. We've talked about tilt a lot, trough tilt a lot on this channel. It's basically just referring to the axis of the trough. Positive tilt troughs have an axis that leans toward the right. Negative tilt troughs have an axis that leans back toward the left. And we like to see, for severe weather purposes, more negative tilt troughs. Not to say robust severe weather can't occur with positively tilted troughs, but negatively tilted troughs tend to have a more robust environment associated with them. Stronger temperature advection, creating stronger instability, and stronger wind shear. Usually a stronger, the negative tilt nature of a trough typically means that it's closer to maturity, and therefore a stronger trough aloft influences what happens at the surface, meaning that there will be a stronger low-level response, stronger low-level jet, stronger surface cyclone associated with a negative tilt trough versus a positively tilted trough. So the fact that we have a nice negatively tilted trough moving in here is going to be a positive for severe weather, although the main forcing is going to be situated to the north of the overall area. You see down here, there's our enhanced risk area. It's just going to receive a very glancing blow from the main trough here. So we're not going to be in the exit region of this trough where we'd have very strong kinematics, very strong forcing for ascent. So we're going to be a little bit farther removed. That's going to mean the forcing is going to be a little bit weaker. We're going to have to rely on strong warm advection, which we will have in spades, but we're going to have to rely on that strong warm advection to be our main forcing mechanism for storm initiation in that environment down to the south. But very strong trough nonetheless, but we will receive a glancing blow down here, which will limit the overall forcing for ascent, at least from a synoptic scale, large scale perspective. Let's go down to the surface and see what happens with the surface. So let me zoom in here to our southern plain sector. So you see not much going on right now, and as we finally get that trough to eject into the southern plains, we'll start to see a surface low develop. This is at 21Z, so this is at 3 p.m. Central Time tomorrow when we really finally start to see that surface low develop there into West Texas. Some semblance of that earlier on, going into the late morning, early afternoon hours. So we will see that surface low develop somewhere in there. That will help to back and strengthen those winds at the surface to out of the south or south-southeast, continuing to pull that moisture northward into the region. And we will see that warm sector start to develop here across southeast Texas. Let's see our dew points as well, given that we have, actually, before we do that, let's go ahead and look at the 850 millibar map. So here's our 850 millibar map, looking for our low-level jet, that layer of winds about a kilometer off the surface, that really helps to, number one, initiate strong, warm, moist advection, and number two, helps to increase low-level shear in a given environment. So again, let me zoom back out here real quick and show you why we're going to see such a strong low-level jet, because as we saw at the surface, we're not going to see a very robust surface response until that trough really ejects into the midday, early afternoon hours tomorrow. But we will see, you'll see that strong low-level jet develop across Texas and really stay put for much of the day tomorrow. So the reason is that we have, again, as we saw earlier, we have a very strong ridge of high pressure located out here across the Gulf Coast states. Well, as that trough moves in, we're going to see a low-level cyclone start to develop out here associated with low pressure. Given that we have this high pressure and low pressure in fairly close proximity to one another, that's going to create a very strong pressure gradient. That is going to allow, the pressure gradient, as we know, modulates the speed of the winds. So as that pressure gradient really starts to tighten, we'll see those winds across the southern plains into South Texas really start to ramp up into the overnight hours and really stay put going into the day tomorrow. And that's why we'll have a very strong low-level jet. I'll zoom back in here, and you'll see the low-level jet is just cranking as we go into the morning, especially into the afternoon hours tomorrow. We see even some purple in there, 70-plus knots here, modeled by the NAM across northeast and east Texas late tomorrow afternoon, early evening. But still, throughout the day, much of Texas, the eastern half of Texas especially, in that 50 to 60 knot range for our low-level jet. That is very impressive, and that is going to lead to, number one, extremely rapid and efficient moisture advection, pulling that low-level moisture northward into this area, and number two, very strong low-level shear. We saw our winds aloft out of the west-southwest beneath this very strong south-southwesterly flow at 850 millibars, our surface flow out of the south. That creates very strong veering winds with height, very strong low-level and deep layer shear favorable for supercells, potentially significant supercells. So let's go back to the surface. Again, we saw that surface low develop here going into the afternoon hours tomorrow. That will move off across Oklahoma into Missouri, going into the evening hours, helping to continue to pull that moisture northward through the day. Now here's our dew points. You can see they're well off the coast, and this may actually be an overestimation. We saw on our surface map here, if we go back to our surface data, you see here across the western Gulf, we see 40s and 50s right now across this area. So this may be a little bit of an overdoing here, but nonetheless, we'll start to see that moisture really start to get pulled northward going into the morning hours tomorrow. That warm sector makes its way onshore. This is at 12Z, 7 a.m. Central Time, or 6 a.m. Central Time tomorrow, excuse me. That warm sector starts to make its way onshore. We should start to see some activity accompanying this surge of northward moisture, at least some warm advection showers start to make their way onshore as early as tomorrow morning. That warm sector continues to spread northward going into the early afternoon, going into the midday, early afternoon hours. Our warm sector extends from basically San Antonio to the Austin area and areas east and south. This is just one model, so the actual positioning of the warm sector may be slightly different from model to model, but overall the idea is the same among the models. Decently sized warm sector here, plenty of room for supercells, and again, the warm advection regime is going to be the main forcing mechanism for storms in this environment. You'll see these bands of showers and storms move onshore, but there's going to be a lot of them. There's going to be a lot, with this very thick low-level moisture, is going to come a lot of cloud cover and showers in the warm sector. So that is going to be one factor that we're going to have to watch tomorrow that could really modulate the overall intensity of the threat. The degree of destabilization in the warm sector. We're going to have, again, a lot of moisture being pulled northward. That means usually a lot of clouds, a lot of showers in the warm sector. But if we can get some breaks in the clouds, that is going to allow for some stronger destabilization and allow those storms to become a better chance to become surface-based and become the tornado producers that we might expect in this environment. So again, as we go through the afternoon, that warm sector continues northward, almost reaches the Dallas-Fort Worth metroplex here. So that would be a little bit, that is going to be something to watch tomorrow as well. If we can get, the farther north the warm sector gets, the farther north the overall severe threat is going to get, because as we saw, that low-level jet is really strong across the entire region. So if we can get robust moisture and surface-based development up here into the Arklatex region, northeast Texas, we could see an increase in the overall severe threat there, perhaps the tornado threat as well. This particular model gets the warm sector up almost to the Dallas-Fort Worth metroplex, so that is something to watch for sure. Wherever the warm sector is going to be where our main severe threat is. So we'll have to watch that as we go into tomorrow. And then as we go into the overnight hours, we lose that warm sector as the low gets pulled off to the east, and we'll see our threat diminish for the East Texas, Louisiana area. All right, let's take some soundings here. I'm going to go through the entirety of this event here. We'll start at 12Z along the Texas coast, down here by the Victoria, Corpus Christi area. Again, at this point, it's still 7 a.m., so destabilization should be fairly weak at this point. But we do see a little bit of instability here, and you see those wind profiles are already very impressive. And this is, again, at 7 a.m. tomorrow morning, or 6 a.m., tomorrow morning. Instability, definitely adequate for to support robust updrafts. Low-level thermodynamics are a little bit problematic. You see a very saturated profile here in the low levels. That is going to lead to very weak low-level lapse rates. You see that 0 to 3 kilometer lapse rate only at about 5.3. We want to get that above 6 degrees Celsius per kilometer. That leads to more robust, more efficient rising motion, efficient updrafts there. So that is going to be of concern. In these sort of tropical type environments, this doesn't matter all that much because you can have very strong shear to overcome that, but that will be something to watch for sure. And usually a saturated environment like this means a lot of low-level cloud cover to work with. So that'll be something to watch again for sure. But look at these wind profiles. I mean, it's hard to beat this if you're looking for tornadoes. Strongly veering low-level winds with height. And we're really not even at the height of the low-level jet at this point. But 7 a.m., 6 a.m. Central Time, and we already have effective storm relative helicity over 500 meters squared per second squared. Strongly curved low-level hodographs. That is very, very impressive. Lots of streamwise vorticity as well. Again, streamwise vorticity is when we look at our storm relative wind vector in comparison to our horizontal vorticity vector, which is perpendicular and to the left of the hodograph. If those two are parallel, then that means we have strong streamwise vorticity, and that is more favorable for aiding in tornadogenesis in supercells. So that is a very impressive wind profile, and we're already destabilizing there along the Texas coast. We'll have to watch that for any of those little beans coming ashore. Could take advantage of this environment and produce tornadoes as early as tomorrow morning. Let's go to 18Z, so right about midday, probably when the event is going to be at its peak. We'll take a sounding here right in the middle of the warm sector, just to the northwest of the Houston area near College Station. And the environment should remain pretty darn good here. And you see, yeah, very impressive environment here. Very much the same, though. The instability is definitely adequate, 1,300 joules per kilogram of mixed layer CAPE. You do notice it is very skinny, though. The low level, very saturated lower half of the atmosphere. You see that the green line and the red line, our dew point line and our temperature profile, very close together, basically below about 500 millibars. A very saturated environment. That often means lots of low-level clouds to deal with, and the overall lapse rates in this layer are very, very weak. You see sub 6 degrees Celsius per kilometer there in the lowest levels of the atmosphere. Again, it doesn't often matter too much in these tropical-esque environments, but we do have adequate instability to support robust updrafts, but the instability overall is a little bit on the skinny side. So that may thwart the overall severe threat as a whole. But again, look at the wind profiles, 500 meters squared per second squared, effective storm relative felicity. Very strong low-level shear as that low-level jet ramps up to 50 to 60 knots by about midday or so. So that is very impressive low-level shear. Any supercells that can manage to maintain themselves in this environment will have the chance of producing tornadoes. And again, given such strong low-level shear, I would not rule out the threat for a conditional threat for a significant tornado or two. With such strong low-level shear, you really can't overlook that risk. So at this point, the warm sector will continue to move northward, 21Z, 0Z. We'll take a sounding here. We'll start to lose a little bit of support, and the storms may not be as robust here going into the early evening hours. But nonetheless, the severe threat will continue. Probably will maximize around late morning to mid-afternoon or so before things kind of wane going into the early evening hours there. Up by Dallas-Fort Worth, again, we'll have to watch that for sure, how far north the overall severe threat gets. We are closer to the center of the trough, farther north, so that would support a little bit greater of a hail threat, perhaps. Again, the convection up here is likely to be a little bit elevated, but nonetheless, we will have a threat for maybe some hail given some steeper lapse rates aloft. Instability, again, on the weak side, but there is a threat for maybe some isolated large hail. And if we do get destabilization up this far, we could see an isolated surface-based storm or two, which would foster a tornado threat given at least adequate low-level shear. But again, the main threat is going to be down to the south, areas along the Texas coast northward to kind of the College Station over to Houston, to Lufkin type areas tomorrow. So and then the threat may, again, this is just one model. The overall warm sector may be a little bit farther east, maybe a little bit farther west than what is progged here, but the overall idea is the same. So anywhere in East Texas, again, especially that enhanced risk area, needs to be on alert. The SPC has it pretty far east at their latest outlook. So the NAM may be, as it usually is, on the western edge of the guidance envelope. So keep that in mind. But the idea is the same. The idea over the overall meteorology is going to be the same, but they have the overall risk area a little bit farther to the east than what some of the other models are showing. So, Houston to Lufkin and areas in between there under the gun for the greatest threat. But that could shift a little bit west, could shift a little bit east into far western Louisiana. We'll just have to wait and see how things go. All right, let's look at some convective allowing models. We'll just, again, we take these with a grain of salt this far out, as they're not that good this far out, but it at least gives us an idea of what we might see on radar come tomorrow morning and afternoon. So you see overnight we start to get these bands of little showers and embedded thunderstorms moving onshore. Again, probably will be associated with a lot of cloud cover, lots of showers in here that may thwart instability overall, but we start to see some more robust updrafts by late morning to early afternoon. We could see some more robust cores in there, especially closer to the coast where the instability is going to be greatest. Dew points are going to be highest closest to the coast. That is near the Houston area, so Houston definitely needs to watch out there. And then we start to see these bands of little beans, I like to call them, just move ashore in this warm advection regime. A couple of stronger cores there moving toward the Louisiana-Texas border. We're not going to see overall a lot of updraft helicity, the spin of the updrafts that the models can estimate. We're not going to see a lot of that in this environment. The models tend to struggle with that in these environments, these tropical type environments. But you can see some of these storms. You can see the little bean shape with these storms, meaning that they very well could be supercells. But again, it all depends on the destabilization tomorrow, and then the threat will move into Louisiana. Going into the overnight hours, there is a marginal risk for Friday out here across Mississippi, Alabama, Louisiana, for the threat as it moves off to the east there. All right, let's look at the ARW model. See what goes on with this model. You see overnight, lots of showers here, lots of blue colors there, meaning lots of showers in that environment. Some stronger supercells offshore, some stronger cores onshore, but definitely a little bit of a mess in this particular model. We'll have to keep that in mind. This could very well be a scenario. If this comes to fruition, lots of showers, lots of cloud cover, could thwart the overall severe threat, mainly just be a heavy rain and some embedded thunder type of an event. NSSL WRF model. Let's see this one. And we see, again, a lot of showers coming onshore. Some stronger attempts at updrafts there, moving ashore, but again, not a whole lot to speak of as far as supercell-looking entities in that blob there. And then we get kind of a squall line, broken squall line to develop into Louisiana, into the overnight, early morning hours Friday. So it's a little tough to tell. This is certainly a conditional threat based on the instability in the environment. If we don't get enough destabilization, if we're socked in clouds and showers all morning, then we're not going to see the severe threat come to fruition. But if we can get a little bit higher moisture in place, or a few more breaks in the clouds, that will help destabilization a lot, and then we will be able to realize surface-based convection in this area, which will have a tornado threat, and again, a conditional threat for a strong tornado or two, given such strong low-level shear. But that is all dependent on the destabilization in the environment. But again, enhanced risk here in the orange area, Lufkin to the Houston metro area. Would not be surprised if they do keep the enhanced risk to extend this maybe down a little bit farther to the coast. Again, the strongest instability is going to be farther south you go, so closer to the Texas coast. Would not be surprised to see a few little beans start to spin early in the morning as they come on shore from Victoria eastward to Galveston, Houston area. And then the main bulk of the risk will come as they move into this area here with the tornado threat maximizing there, given a strong low-level jet. Again, 10% risk for tornadoes, conditional threat of a strong tornado or two. They don't have any hatching here indicating that they're forecasting strong tornadoes, but given such strong low-level shear, you really can't discount that threat. But there is a 10% tornado threat coincident with the enhanced risk area, and a large 5% and 2% area surrounding that. And again, if we can get the farther north we can get surface-based destabilization, the farther north that tornado threat will exist as well. And then we do have a damaging wind threat. Some of these storms could produce a few sporadic damaging wind gusts, and then a hail threat as well, especially farther north where the lapse rates aloft are a little bit steeper, closer to the center of the trough where there is colder air aloft. So larger hail could be a threat with elevated storms up here into southern Oklahoma and northern Texas. So that is going to be the threat for now. Not sure if I'll be able to do a video tomorrow morning, as I may be out chasing this setup. It is a long drive for some of the cons that are at play and some of the uncertainties as far as destabilization goes, but the forecast shouldn't change too much going into tomorrow. It's going to be a very much a wake up and see type of day based on how the destabilization goes in the environment tomorrow. So that's going to do it for this video. Thanks for watching, and we'll see you in the next one.